Hello students, I'm Miss Slate and today we're going to talk about how to draw Lewis dot diagrams. So open up your chapter 5 note packet to page 14. It should be the very back cover. We've already learned about electron configurations, where an electron configuration shows us all of the electrons in all of the orbitals in a particular atom. But sometimes we're only interested in the outermost electrons of an atom. Those are called valence electrons. And the valence electrons are electrons that occupy the atom's outermost s and p orbitals. And these electrons are always associated with the atom's highest principal quantum number, or their highest energy level. So if we were to look at our examples above of sodium and magnesium. For sodium, its highest energy level is 3. And so it has 1 electron in its 3s, so we'd say it has 1 valence electron. Likewise with magnesium, its highest energy level is also 3, and it has 2 electrons in its 3s, so we'd say it has 2 valence electrons. The other electrons in the atom that aren't valence electrons are called kernel electrons, and they are the electrons that occupy the inner orbitals. But really what we care about the most are the valence electrons, because the valence or outermost electrons are the ones that are involved in chemical bonding to form compounds. So the first thing that we're going to do is we're going to start off by writing the electron configuration for our 4 example elements here: nitrogen, sulfur, calcium, and cobalt. Because writing out the electron configuration is one of the simplest ways to determine the number of valence electrons. So there are electron configurations for nitrogen, sulfur, and calcium. So the first step of writing a Lewis dot diagram is determine the number of valence electrons in the element. And those are the highest energy level s and p electrons. So nitrogen, its highest energy level is 2. There are 2 electrons in its 2s and 3 in its 2p. That's a total of 5 valence electrons. The next step to make a Lewis dot diagram is to write the element symbol. The symbol for nitrogen, the symbol for nitrogen is a capital N. The last step is we're going to place dots around the element symbol equal to the number of valence electrons. And notice how we arrange the electrons, right? So the s electrons are going to go at the top of the symbol, and then the p electrons will be spread out around it. So there's 2 in its 2s, and then 3 in its 2p. Now remember though, Hund's rule tells us that electrons in orbitals of equal energy will spread out before pairing up. So I'm going to put I'm going to put my dots for each p orbital on different sides of the symbol. So 1, 2, 3 for my 3 in the 2p. So my 2 electrons in the 2s are at the top. My 3 in the 2p are around the 3 sides. Again, because electrons in same energy orbitals are going to spread out before they pair up. And that's because electrons are negative and they naturally repel each other. Let's look at sulfur next. Step number 1, determine the number of valence electrons. So there's 2 in its 3s, 3 being its highest energy level, and then 4 in its 3p. That's a total of 6 valence electrons. So then I would write the symbol for sulfur, capital S. And then I would draw dots around the S to represent its 6 valence electrons. So the 2 s electrons go at the top, and then I spread out the p electrons before pairing them up. Six valence electrons around sulfur. Next is calcium. Calcium, its highest energy level is 4, and it has just 2 electrons in its 4s. So then I'd write the symbol for calcium, capital C, lowercase a, and I'd draw the 2 dots for its 2 s valence electrons. Then we come to cobalt. If we look closely, 4 is its highest energy level, and it has 2 electrons in its 4s. And that is all the valence electrons it has. Remember, energy level drops by 1 in the D block. So 3D is lower energy than 4s. And your valence electrons are only ever going to show up in s and p orbitals. D and F orbitals will never be valence electrons. Valence electrons are always in just s or s and p orbitals. So for cobalt, I'd write the symbol for cobalt, capital C, lowercase o, and then just 2 dots for its 2 valence electrons in its 4s orbital. And that's how you draw Lewis dot diagrams for elements.